The James Webb Space Telescope has been investigating the faintest objects for answers about the universe. This NASA's new eye above has been tracking down dazzling pictures of stars, gigantic designs, and planets. In any case, at last, something unexpected has been found. Something so huge it could shake the very spines of all that we understand. It has scientists scratching their heads and assessing whether it could provoke the farthest requirement of everything. Join us as we explore how the latest discoveries of the James Webb Space Telescope could demolish our understanding of the universe. When we explore the edge of the universe, we are talking about the observable universe. The visible universe seems like a window through which we can look at the magnitude beyond. The observable universe encompasses all that we can presently perceive, measure, and investigate using our telescopes and space probes. It's a collection of stars, galaxies, and heavenly bodies within our grasp of understanding. Regardless, the observable universe is just a small part of the entire universe. Envision it as a slice cut from a tremendous, immense pie that we're able to study and comprehend, while the total size and shape of the universe at large remain a mystery. Scientists estimate the width of our observable bubble to be around 93 billion light-years. A light-year measures the distance that light, the fastest thing in the universe, travels in 1 year, about 5.88 trillion miles or 9.46 trillion kilometers. So, when we discussed the breadth of the observable universe being 93 billion light-years, we're talking about a colossal stretch. Around 13.8 billion years ago, the universe burst into existence in an impossibly strong impact. This event started what we call the Big Bang. Since that tremendous birth, the universe hasn't just been expanding, it's been accelerating in its expansion. Baffling forces like the mysterious dark energy seem to be driving the speed up, stretching the boundaries of the universe further and further apart. As the universe expanded, matter began to clump together under the influence of gravity. This gravitational force joined particles, birthing stunning structures, stars, massive galaxies, and eventually planets like our own Earth. Picture the universe passing by as these colossal structures formed, evolving into the unique yet constantly growing oddities we see across the universe today. Despite its vast size, the universe is incredibly empty. If we were to shrink our entire solar system to the size of a quarter, the nearest star would still be about the length of 2 soccer fields away. This vastness extends right within our own Milky Way galaxy, which is just one among billions in the observable universe, giving us a sense of the sheer size of infinite space. Now you may ask, why can't we simply see everything that exists in the universe? There are several reasons for this limitation. Most fundamentally, light, the fastest thing known to man, still takes time to travel through space. This means that when we look at distant objects, we are essentially studying the past. The farther an object is, the more time its light has taken to reach us. It's like looking through a vast time machine, unrolling the history of our universe as we observe galaxies millions or even billions of light-years away. The real universe is expanding. Imagine spots on the outer layer of an expanding balloon. As the balloon inflates, the spots move farther apart. This same principle applies to the universe. Galaxies like those spots are drifting apart as the fabric of space stretches. This expansion causes the light sent from distant objects to undergo a shift known as red shift. Essentially, the wavelengths of light stretch as the objects move away, shifting toward longer wavelengths, often appearing reddish in color. Given these factors, light's travel time, the expansion of space, and the universe's constant progression, it's not surprising that we haven't yet fully seen all that the universe has to offer. Even with our particularly advanced telescopes and technology, our view is still restricted by these key properties of the universe. The journey to grasp the possible edge or limits of the universe has captivated the minds of countless people across disciplines, while definitive answers remain elusive. Three prominent theories have emerged, each offering intriguing perspectives on the propagation of infinite space. The first theory suggests that the universe expands hugely, continuing forever without an observable edge. This idea aligns with the cosmological principle, stating the isotropy of the universe, its consistency and appearance from any vantage point. If this principle holds, it suggests that the universe lacks a boundary and continues expanding infinitely in every direction. The second theory offers an alternative view, suggesting that while the universe may indeed be finite, it lacks a clear edge. Instead, it may resemble a vast circle or a warped space, much like Earth. In this scenario, if one were to travel forever in any direction, they would eventually return to their starting point, much like circumnavigating Earth. The third theory, the multiverse hypothesis, presents a fascinating idea that our universe is just one of countless others. Imagine an infinite number of parallel universes, each existing with its own set of physical laws, constants, and properties. These universes may be entirely separate from one another, functioning independently, or they may be interconnected through complex systems, forming a vast and intricate multiverse. The James Webb Space Telescope, JWST, stands as a symbol of potential, illuminating the mysteries that lie at the vast origins of the universe. This incredible instrument has an unparalleled capacity to unravel the confusing past of our universe, allowing us to peer far beyond what was previously possible. The JWST is a technological marvel designed specifically to observe the universe with remarkable precision. Its advanced capabilities stretch our vision to the earliest moments of the universe. In fact, a groundbreaking study published in the renowned journal Nature revealed the JWST discovery of massive galaxies dating back between 500 million and 700 million years after the Big Bang. Astonishingly, these ancient galaxies are far larger than expected for their early existence, challenging the prevailing theories of galaxy formation. Furthermore, their development in the early universe is truly remarkable. What's extraordinary about these discoveries is the level of sophistication in these ancient systems, contradicting the assumption that galaxies form slowly over time. These massive galaxies exhibit a level of complexity comparable to our 13 billion-year-old Milky Way galaxy. The sheer number of stars within these titanic behemoths surpasses our expectations, with each galaxy boasting a total mass several times greater than our Sun. Strikingly, one of these galaxies may even have a mass up to 100 times that of our Sun, overshadowing the already enormous size of our Milky Way. The JW's unmatched ability to explore the universe's hidden spaces is based on its use of infrared light and invisible range to the naked eye. This remarkable power enables the telescope to capture the faint emissions from ancient stars and galaxies, revealing immense remnants that have endured for billions of years. Essentially, the JWST acts as a time machine, moving our vision back through the ages and offering a captivating glimpse into the universe as it appeared roughly 13.5 billion years ago. The continuous discovery of massive galaxies, eagerly nicknamed universe breakers, has revolutionized our understanding. It's like rewriting history, a stunning twist that challenges many of the models we had established for early galaxies. Initially, we believed galaxies formed from humble beginnings, starting as small collections of stars and dust. They were thought to evolve gradually over time, increasing in size and complexity. However, the universe breakers have shattered these notions when the JWST data and its high-resolution images are revealed. These colossal structures, these massive behemoths, appeared seemingly out of nowhere, as if they had only just been discovered, amazing. Our previous understanding of cosmic evolution was dug deeper when researchers used spectroscopic techniques to analyze light across different wavelengths. This analysis holds the key to unlocking vital insights about these mysterious galaxies, such as their structure, size, and distance from Earth. It's like a vast investigative story with light as the key to uncovering the secrets of these giant entities. The astonishing discoveries from the James Webb Space Telescope have transformed our understanding of the universe to unprecedented levels. This cutting-edge telescope, built by a global team of space scientists, has recently revealed a stunning discovery: the identification of the oldest and most distant galaxies ever observed. These galaxies transport us back to when the universe was just a tiny fraction of its current age, existing only a short time after the Big Bang. The James Webb Space Telescope, out in the vast darkness of space, has been searching for answers about the universe. It's NASA's latest powerful instrument, capturing breathtaking images of stars, galaxies, and planets. Recently, it made a discovery so remarkable that it could change how we understand the very fabric of the universe, leaving researchers baffled and curious about its potential implications. When we study the universe, we begin with the observable universe, a window into the infinity beyond. This observable universe includes everything we can currently detect with our telescopes and space probes, including stars, galaxies, and other celestial bodies. However, it's just a small part of the entire universe. Scientists estimate the width of our observable universe to be around 93 billion light-years. A light-year measures the distance light travels in 1 year, approximately 5.88 trillion miles, making the reach nearly limitless. Around 13.8 billion years ago, the universe began with a Big Bang, an enormous explosion that triggered the Great Expansion. Since then, the universe has been developing and accelerating, driven by mysterious forces like dark energy. Matter began to coalesce under gravity, forming stars, galaxies, and ultimately planets like Earth. This ongoing process shapes the universe's immense size, allowing us to observe just a small piece of its endless complexity. Even with the expansion, much of the universe remains dark and empty. Despite how far we've come in exploring space, most of it remains hidden. Even with the power of the James Webb Space Telescope, vast portions of the universe remain out of reach. Still, its discoveries continue to reshape our perception, offering a glimpse into the incredible wonders that lie just beyond our sight.